The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Hi, welcome back to the Electronics Inside, the show where we tear down toys, tools and appliances just to find out what's inside. I'm David, and today we're having a printer showdown. What difference has 30 years made? So what we're going to do is compare a, let's call it vintage, dot matrix printer and a modern inkjet printer. I want to start with the classic and find out what's inside. So this wonderful little printer is, I don't want to say the name of the company because I'm pretty sure I'm going to be pronouncing this wrong. Oki? Please someone let me know. Now, when we first had a home computer, we had a dot matrix printer, and these were the printers we had at school as well. Now, I find there's something distinctive about the sound they make. And these were loud. These used to be sold with acoustic enclosures. So they'd like have a slot for the paper in and paper out, but otherwise they'd be acoustically lined to keep them quiet in an office environment because, yeah, they were loud. Ooh. That was easy, 2 screws and I'm basically in. It's never that easy. One thing I should have said before I started, there should have been a knob that went on the outside of the main roller. Now, for whatever reason, that was missing before it came to me, so sorry. So inside we have the ink cartridge, which is a ribbon style, which I can't remember how it comes out, something along those lines, there you go. There's a little continuous ribbon which runs around on the inside of here. It's all spiraled up, runs around. There's a little cog that engages on the bottom here. So as I push this head forward, you can see it spins. Now that turns this little wheel, which you can also forward by hand, which has the ink pressed in it. I don't want to touch it because I'll just wipe ink everywhere, but the pins fire through that and imprint that ink onto the paper. Seems really simple. I mean, that's the same fundamental mechanism as a typewriter. Now, this model, as far as I can work out, was released in 1984, which makes me feel good because it's actually older than I am. But typewriters and that technique of what's known as impact printing is super old. There you go. So these are the buttons on the front. These tack switches, I think, are... Well, maybe it's not the tack switches. They're a bit crusty and a bit ropey. Maybe it's the plastic is just full of rubbish on the front. And 3 LEDs. And that is all the interface you get, really. Nice little board edge connector in there. So yeah, this type of printer, dot matrices, fall into a class of printer known as an impact printer. And the name is pretty much exactly what it sounds like. These are printers where they impact the paper and the ink and medium to get the font up. Now with a dot matrix, that's obviously made up of dots like pixels in a picture, but they can only be black or white. But they can at least reproduce dithering effects and dot matrix and bitmaps and things like that. However, previously to dot matrices, you had things like daisy wheels, which were a little bit like typewriters, where they had an individual arm with a stamp which represented each letter on it. Much more limiting. You couldn't even vary the font. It was physically built into your printer. Now, dot matrices, they made life a little bit more convenient. Now, I'm lucky enough that I did find, well, it wasn't even the service manual for this thing. The user manual for this device went through user servicing and replacing of the fuses on the power supply, and the inclusion of this, which is actually a serial upgrade card. So this was a serial port. It's a 25 pin, yeah, a D25 connector and an extra add-on card for serial communications. RS232. A cap has started leaking. It's gonna die. For a machine that is 35-ish years old, you can kind of forgive it. A couple of leaky caps. For anyone that's interested, it can't make its mind up whether it's European or UK, but equally it works on both. 240 volt is fine. Serial and a model. This model was 84. I'm not sure when this device was, but I do know, based on the diagnostics printout, that this was actually had a memory upgrade. Okay, transformer. Now, I have had this on recently, so I need to be very wary of any capacitors. Oh, that'll do it. So that transformer, very nicely, it's a completely standalone module. Then you've got this board, which is just a fuse, a couple of caps. So is the rectification done on the main board? Yeah, it looks like it. Looks like it's still AC, low voltage, but AC straight out the transformer onto the board. So I guess we take the main tray out first. Anybody that doesn't know, these little wheels up here are for what's called tracked paper, and you can get the sort of concertina or fanned paper. So there's a slot on the bottom where you could put this in a mount and have it feed the paper in from the bottom. Those tracks run up the side of the paper and engage with these rollers to make sure that you always get a consistent feed. As you will see from this, I didn't always get a consistent feed rate when I was using normal paper. By the time I started using printers, the notion of this marking on this little bar was totally lost on me, because I started using computers in sort of Windows 3.1 and up, so I was already into graphical user interfaces, and the notion that this had 80 columns marked on it meant nothing. Of course, today I recognise that as text-only computers that had an 80-column display meant when you pressed print, you had 80 text columns on your print as well, so it exactly matched what was on the screen. Not the sort of WYSIWYG you get today, but it gave you some kind of idea of what was going to come out the printer, I guess. Oh, look at that connector. So obviously there's a flexible ribbon which goes to the print head across here. That makes sense. And there's an edge connector down here for the buttons and LEDs on the front. But this PCB and the little push fit connector on the bottom here, that hadn't expected that. It's actually only a container, yeah. So it's actually an edge connector on the board as well. That's kind of cool, although I've nudged some of those pins out of place. So there's a 40-pin press fit connector. Cool. So how do you come apart? Now that's obviously the drive motor. I still want to get my head around the rest of this. So this is the print head. This is the bit with the actual pins in it. Kind of hoping we might get some more detail out of that. But yeah, it's a cool little PCB. Just these little traces, they're all hand drawn. Somebody spent hours labouring over that. Another little pin transfer connector. I feel like on a modern printer that would have been engineered out as an unnecessary assembly. And the pins on this just pressed into the back. I can already feel that's magnetic slightly. So on here we've got the feed motor, which also has the transfer to the top for spooling the ink ribbon. So that drive would have come over here to this pin before I destroyed it all. Interesting, those motor feed pins are actually these 6 over here. Come down on that little connector on the back. Let's see if we can get that motor exposed. Oh, I didn't see that coming. Rotary encoder and a light gate. Oh, that's amazing. There we go. So here's the main paper roller, and again you can see those tracked pins on the side. Feed that paper through. I'm never getting those pins out of the roller in the centre. So unfortunately you'll just have to kind of imagine that I've taken that bit apart. Motor's dated May 1988, and this is a 7.5 degree stepper motor. The nice normal voltage of 6.63 volts. Common. Before I get too carried away and move on to the inkjet, I've got the bit I was actually looking forward to. Now this head is the bit I know so little about. Ooh. Oh, and it's super magnetic. I don't really know what to expect in here. I'm pretty sure I'm going to lose an eye trying to take this apart and probably stab myself in the finger. I've genuinely been curious since I was about 8 years old, so no time like the present. So this part is the bit which would run along the ribbon and the paper, and it's got, I can just make out probably 5 pins that would have punched the paper as it ran along. Okay, there's the back casing off. This little PCB which was down to the connector on that board. 1, 2, 3, 4, 5, 6, 7, 8. Does that mean there are 8 pins? Does this with a little bit of sponge on the bottom? Oh, the other thing I should say, hot. Apparently these things get very hot. It's quite common to see them with heat sinks on them. Ah, we go. Oh wow, that's so cool. So these little strands are each of the pins. So the pins aren't even straight. Oh, that's incredible. So there's 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that corresponds with the 8 on the back. And each one just has this little rock of motion, which is presumably, very presumably, electromagnetically actuated. And when they go through that tiny little slot on the front there, they all make a vertical line of 8 pixels. I should say right off the bat that I made no apologies for having mucky hands, because I've taken an inkjet printer apart before, and if you think it's bad after a 30-year-old dot matrix printer, trust me, it's going to get worse before it gets better. I'd also like to say, if I start making any insults or jibes at the build quality or anything about this machine, it is not a direct response to actually this machine. It never worked when I bought it, so I don't know how good or bad this one was. It's just a generalisation on the kind of build quality of modern printers. They are almost a consumable. And if you've ever bought a printer and thought, I need new ink now, that's cost me nearly as much as a new printer, you're not alone. So the first obvious thing about this printer is it's not just a printer. Got a nice big scanner on top. You've got the SD card reader on front, it's Wi-Fi enabled, you've got various paper trays. The whole thing's like completely automated and has so many more functions and features. But as always, we're only interested in the bits on the inside. Ooh. Well, that was a bit kind of all at once. Okay, let's discard the bottom half for a moment and explore a little bit more up here. Okay, so this is obviously the glass plate from the scanner bed, and along with that we've got the buttons, the menu, an SD card reader and a USB port. Now they all sit on this little daughter board which has a ribbon connector. That's super annoying. I've actually got to take the glass out to get to the last screw to get the screen out. So there you go, just a series of tack switches, SD card, USB. I suspect there's no ICs on here at all. No, it's all just passives. So it's all just signal management, and all of that data will be passed back down this ribbon, back to the main board. So this is cheap, disposable, but not without destroying your scanner flatbed anyway. So now on this one, we see this fixed rack. Got it right this time. It's just driven by a motor with a worm gear, geared down that runs along this track. Again, tiniest, really high resolution encoder wheel and light setup, light gate setup. It's the optics on here which always fascinate me. This bar has got a set of LEDs for a light source, but also sensors, and I've never been able to work out how these sensors work. So on with the base. Now in terms of printing, this is where all the business end is. And here we have the black ink cartridge. Before anyone asks, no, I'm not going to take the cartridges apart because that's just a recipe for mess everywhere. So this DC motor is driving the head, and it gets positional feedback from this little ribbon, which I'm really struggling to get out. Hold on. So this little ribbon, I'm never getting this, but is actually made up of tiny, tiny little stripes like the rotary encoder wheel we just saw. Now this provides the feedback for the position of the motor. And actually you can see on this end, it's already got some ink stains on it. So that's probably stopped working. Right, so in this printer, we've moved from this rotary encoder on the motor of the print head to a DC motor and this linear encoder strip. Oh, the other thing I should also mention, which I haven't covered already, is it's no onboard power supply. This just takes, I think it's a 19 volt external power supply, so you don't need a transformer, bridge rectification or mains voltage in here at all. Of course, that's probably a feature of international selling, that they just change the external power brick, nothing inside has to change. But it also keeps the cost of components down, because they can buy that external power brick en masse, just ask for it with different labels on it from the manufacturer. Wow. 4 screws are all that's holding that in. The other inkjet that I took apart also had this sort of foamy stuff in it that was just soaked in ink. Now, that has to be waste. I can't picture any other purpose for it. And the fact that that much is being lost inside, knowing how much it cost for one of these ink cartridges, that would drive me furious. I'd be so cross if I found out that most of it, or even some of it, is just being soaked up inside the machine by a sponge for apparently no clear reason. If you can think of a good reason why that happens, and don't say cleaning, because you normally need paper for cleaning, answer in the comments below. I was just about to say, what on earth is this? That, down the front, is a little Wi-Fi card. And of course it wants to be up and out the front just to get the antenna as clear as it can be. Right, oh, wow. Okay, all right, so on the back here, there's this massive, like, array of pins that sit forward. Now, they make contact on the back of this pad here, and the ink cartridges sit in here to supply ink to those pads. So you've got 4 tiny little droplets, literal pipes from each of the colours, and the black, or cyan, magenta, you know what I mean. Now, those little ridges on that assembly are actually just dried up ink, so I don't want to be touching those. See, we used to have an Epson printer, and I don't know whether they still are, but those little lines were actually on the bottom of the cartridge, so you replace those every time. Whereas on this printer, if it's fixed on the printer carriage, and you only replace the ink source, at least the ink cartridges should be cheaper, but it means that these are going to get dirty and wear out quicker or become uncleanable. Now, presumably, that's why you have tons of ink inside the printer, because it's trying to clean itself. And that, I guess, is where it's all going. But I guess within here, you have your little diaphragms or your piezoelectric crystals. They're all potted in there. That's epoxy resin. So under there somewhere, you've got your little inkjet dispersal heads. Yeah, this is what's called a peristaltic pump, or certainly appears to be anyway. And inside this casing, the little silicone hose will be running all the way around the outside, and there'll be rollers on the inside which rub around it. And basically, if there's anything in there, they'll push it round in a circle. Now, peristaltic pumps are called that because it's peristalsis, it's the movement of you swallowing. They're really great for a lot of applications. You can get food safe silicone, so they can put anything you like down it. They're very quiet and can go for a very long time without maintenance. I'm just surprised to see one here that there's so much ink being overused that they need a pump to handle it. Now, like I say, if you're using that much, paying that much for ink, and they're pumping it away to some sponges inside the case, man, that would make me cross. It's making me cross, and it's not even my printer. It's interesting that all these little light gates that are part of the paper handling system, little switch there, are only ever screwed down on one side. Now, that's some seriously hardcore value engineering if you're only using one screw to hold something down. I'm not sure it really needed saying that this has got a more complicated paper path than the dot matrix, but they have a lot of feedback on this, which is good because at least the user can have feedback on where a jam has occurred or what's going on. They don't need to be an expert on it and have read the manual inside out like I had to get the other thing working. So the belt is then pinched in this little carrier on the back. It's actually a notched roller as well. It's a nice little drive belt. And the control wiring goes through this little loom, again glued on. Yeah, I'd like to see a little bit more about what's going on in here. So obviously this light gate just passes through, and I think that's probably the calibration lights. Got a ribbon out there, which I'm not too interested in. Got an external board here. So it's another little light gate. Ah, of course. This is the light gate which actually runs up and down this linear sensor strip like that to gauge position travelled. I don't know why, I kind of would have assumed that there was more integrated circuitry, maybe even a processor on the print head. Kind of like a self-contained unit, but it's not. It's all being done back on the main board. Got the main carriage drive motor. They appears to be the same unit with the same. What's a belt drive sprocket? Is it a sprocket still? There you go. So two identical motors, one for the paper feed, one for the carriage head. A lot of plastic and a lot of ink. So the inkjet printer is clearly more advanced. We've got a colour screen, we've got Wi-Fi, we've got card readers, we've got much better processing, we've got colour ink, we've got inkjet technology, which in itself is incredible. Very, very clever stuff. That electronics that can handle a single drop of ink at all is impressive, but the speed and resolution that it manages, there are thousands and thousands of precisely controlled drops being pushed onto that page every second using this circuitry. It's not something super advanced, it's not something special. There are 2 integrated circuits on here and that drive the whole thing. That's impressive, very, very impressive. But what to me is inescapable is the method of making money out of these things. The dot matrix printer would have been an investment that a business made, and in some cases businesses still use those because punch printers are the only kind where you can still get an original carbon copy. It still happens today where you will get a printed carbon copy, or it won't actually be carbon, it will be the new chemical coated paper, but you have to sign at the bottom, and they will be printed on a dot matrix or a punch printer because they need that duplication. It's a legal requirement in some circumstances. But this printer, I think, must have been probably working since it was manufactured in the late 80s until very recently when I picked it up to demonstrate to you lovely people. But I think we've all been stung by buying a cheap inkjet printer, which has worked for a cartridge worth, 2 cartridges worth, and then for some reason has stopped working. Now look at the resolution on these encoder wheels and the fact that this one, which defines the carriage head position, has actually already got ink spattered on it. That's enough that it will no longer know when it's home. That's enough to stop this printer, that tiny little bit of ink. And the more I talk about it, the more cross I am. The fact that they've actually had to engineer into this thing a pump for removing waste ink. This stuff is so expensive. It's like $50 for 100 millilitres of coloured ink. That's insane. And they're just pumping it away to be soaked away. I mean, that in itself is a finite thing. Once that foam, that wadding is full of ink, where's it going to go? It's going to leak out on your side. I know people have had printers leak like that, and I've never really understood why. That is the definition of built-in product obsolescence. It's a product with a ticking time bomb inside it that's going to stop you using it. I might not be happy with the outcome, but it is absolutely fascinating to see the advances in technology and the change in ethics of a manufacturing process in that timeline. If you've got an idea for a teardown that you'd like to see, let me know over at the Element 14 community at element14.com/the electronics inside. Thank you so much for joining me. I hope you've enjoyed it. I'm going to go wash my hands.